We're gonna look at this homework, and I think this will turn out to have been useful here. Okay, so what you were doing here is you were trying to add a new like grab arm to basically turn X into our like format called like for an example name, right?
That's right.
Okay, just to like orient everyone, we already had an example of doing it for HTML and noun types.
Hmm.
Okay, so the first place that I start here when I'm trying to figure out what the input to text is the thing I want to emphasize that it's super mechanical. Okay, so when I say mechanical, I mean we can actually figure out like what a text looks like by looking at its mark file. So here is like mar slash text.hoon.
Hmm.
And if we look at the top of the door, text is a Wayne.
Okay, so it already comes in as a Wayne. Okay.
It already comes in as a Wayne, and so and we can also look at what I also will look at is like what it does its own grab as when it starts as a noun. And this is basically it'll get parsed by the system, and it just runs the Wayne gate on it to like that mold.
Okay. Okay. And
Okay, so that's
go ahead.
oh sorry go.
A Wayne is it's basically a pat T separated by like fast 0A, which is
It's
like
I'm
carriage
pretty
return.
sure it's just a like alias for list of chords.
Okay, so it's already in the list. Okay, got it.
It's already and the way you would get that if you're not sure if you have this random type referred to that doesn't really seem to be imported from anywhere. I need to see where
Yeah, I
like
had
are
trouble
you,
finding it. That was why I was like, no, I
it's
got it from context.
it's in hoon.hoon where
Oh,
they
there we
usually
go.
are.
Okay.
Yeah, so I always start by searching the sys files, and I always search for like lust and the name or like lust buck.
So I'm I'm dumb and don't know how to use Emacs like you do, and so I was
Yeah.
looking on the GitHub, and you can't search for lusses. Like it just cuts that out of your search. So I think that was
Oh, really?
yeah, and
Well,
then you just get a bunch
whatever.
of Waynes.
Yeah, yeah. What text editor do you use usually?
um, VS Code.
Yeah, so no, VS Code is good. So VS Code is totally fine. So you just search in VS Code for the same,
Okay, yeah, I should do
and
that.
that's what I use when I use VS Code for Hoon. And then I just happened to find there was like a syntax highlighter for Emacs, and I'm in Emacs for normal work, so I just put it there. But it's exactly equivalent, and I've done the same. The key thing is searching for that like lust gap.
Yeah.
And then like you'll see Wayne is a list of chords, and at that point, kind of you're off and running because now we know we can just the first thing is we know we can just have the input here be Wayne, or you could even
Hmm.
do list chord,
Hmm.
and then you kind of do the rest of your logic follows from there.
But otherwise, that's generally what you would do to get that into the format you were talking
Yeah,
about.
exactly. In fact,
Okay.
it's like at that point it just becomes a purely arbitrary, just like normal Hoon transform using all the tricks for taking a list of stuff and doing stuff with it.
Okay. Cool. All right.
Okay, so that's like it's pretty straightforward, and like that lesson is in some ways marks are like less exciting because in practice you don't end up doing a ton with them. And let me what I should make a note for myself here for something to add for actually for the Ford lesson exercise showing how boring most of the marks in MAR are. Okay, like literally most of them are. I have some custom type that either does like a JSON like parsing JSON,
Hmm.
or it just lets me define some like stupid custom type. Okay, for example, if I have all these things like chat or contact, like this is a pretty common case. I have chat and then I'll look at action.hoon, but hook action, view action, they're all super view action. Let's even look at, and literally all it is they say, okay, my thing is going to be an action that I've imported from this chat view library.
Okay.
Right, that's my door. Like
Yep.
that's the sample in my door, and then my grab noun is literally if it's a noun, just run that like action mold on it, and if it's JSON coming in, go ahead and run this like action thing that presumably like parses JSON into my action type.
Okay. Okay, that makes sense.
Okay, yeah, exactly. I mean, we don't want to like. I won't spend forever on it. But we actually looked at Chat View the other day, and this was the one where they did the thing where they like both export sir. They export like all the sirs
Hmm.
into kind of the main namespace from the lib file, so that you don't have to write like type logic in the lib file.
Right. Okay.
Okay, and then again, as we see, so they have so basically our action thing is going to come from the SIR file, like right here. So here's that action mold.
Right. Okay.
Okay, and then we have like the DGES action, like action arm,
Which
which
basically does the same thing.
it exactly it essentially takes JSON and goes through all the different cases that JSON can have to put it into this format.
Okay.
Okay, and I think I actually can, in terms of when we see exactly how to do that with JSON, that's going to be our last lesson of this part, unless I add Backy to it, to the backend foundation. It's this call from outside one. We'll see how to do this JSON parsing. What you need to know for JSON parsing for these purposes, for communicating back and forth with ships, is really straightforward.
Okay.
Okay, so don't it's there is a larger subset of stuff you can do in it, but the basic stuff is like really mechanical and pretty straightforward.
Okay.
Okay. All right. So that's the rest of it. Let me look at after. This is for the grab arm, the grow arm. Um, yeah. So LM, I was sort of saying like, I'll look at that in a sec. From js.hoon, um, it's basically converting the JavaScript into like JavaScript code to be inserted on a page, and that's what like the Mick ones are like special runes for for doing like HTML transformations.
Okay.
Okay,
Okay.
sorry, go.
How did you figure out what was going on there? I couldn't find any documentation of what
Yeah,
Mick
it's
had.
hard to find. I should have given like a hint for that. So I should probably add that to the thing. Like I just like literally remembered that it was like that there were some of those like there in their like sale stuff. It's all even a little bit, I think, obsoleted or not used as much, but there is support for kind of having Hoon parse HTML.
Okay.
Yeah, I should give some hint to that there. The rest of it, okay. So I think the most useful thing out of all there, it's good to like look at the other stuff, but and I'll check it at the end. But the main useful thing is like doing a grab arm yourself, so that you can just see how they're done, and they're fairly mechanical in general.
That makes sense.
So usually you'll be just applying some mold, doing some little calculation on something, which is why I thought it was like pretty reasonable to like, ask how long the thing is and put that there. Or very, very often it'll be some like JSON parsing.
Got it.
Okay. So now we're gonna kind of go to the fun part, which is basically pokes, watches, and the marks to do them. So this is like actually by the end of this lesson, you should feel pretty comfortable just sending random messages to different ships. Now, one thing I did forget that I need to get started is in the background here, and this is just to see how
Pokes
like
watches
Tim.
and the marks who use them sounds like an HBO special from the '90s. Just like
Yeah, it really
it's
does.
real sex. Pokes watches and the marks who use them.
Definitely. Um, let me Tim look and let me. I'm gonna start. I need to start like a fake Tim look ship going in the background here, because we will use that later in the lesson. And I
Okay.
have here. I can go with fake sod. Okay. So let's just jump into it. We're gonna use two, as I say at the start. We're gonna use two fake ships, and so I think we talked before about how those like automatically know about each other. We
Right.
hide them in that like workflow lesson. So that comes up here because it is we do some stuff where the ship talks to itself, because there absolutely is a use case for kind of poking your own ship and subscribing to other processes on it. But I do want to show like how easy it is to talk across to other ships. It's no different than talking to your own ship, essentially.
Okay.
Um, okay, so actually, no different at all. It completely abstracts that detail out. Okay, have you used Tiscat much?
I don't think so.
Okay, so it gets used a ton in
Oh
for a
yes,
specific purpose. Yeah,
I see.
essentially, it looks weird in the definition, but the basic idea of it is I'm going to call a gate, and from it I get back both a result and some updated version of like a state.
Yep. Yeah,
Okay,
this was hard for me to understand when I was reading other people's Gall stuff. But yeah, let's do it.
it's so I think the Gall is actually one of the best ways to kind of understand the purpose of it and why
Yeah.
it's there. Okay, so here's like I think this is like this typical form here is really good, which is I'll show you how to identify it in the code, but the basic idea here is we say cards, state, and then we call a gate. Okay, so it's a little hard because there's not many runes that have four children, so that makes it a little hard to keep track of stuff.
Hmm.
So let's think of it more in terms of like what it's trying to achieve, which is there's this really common thing that comes up, which is you say, okay, I want to process data and get some data back, and also I need to modify my subject in some way before I continue on.
Yes.
Okay. If we didn't, another way to say it is if we didn't have Tiscat, our operation would be a little bit clunky because we would probably get back the result. So instead of cards and state, we could get back something called result. And maybe then we would take cards.result and do something with it. And then we would use like tis.dot to update some wing in the state to state.result, for
Got it.
example.
Right.
Okay. So this basically just gets rid of that. I actually want to just to quickly look at it because like very often for these runes, when you have that motivation and then you look at the expansion, they don't get. Oh no, they have so the expansion here is
Oh,
actually
it like really
like
is that.
yeah. So the expansion is we have P. It basically takes the head and then it uses like tis dot to do the tail on whatever the wing is.
Huh.
So yeah, the expansion is exactly that. It's just this is way less readable,
Yeah.
right? And that's very often the case for most Hoon. They're just actually pretty simple macro expansions.
Yeah.
Now,
Okay.
what does it look like in the code? It'll pretty much always look like something like this. You'll get this top level cast equip card type of this, and then at some point inside it, there'll be some kind of nested thing where it'll kind of go down into the card state mode.
Yep. Okay.
Okay, and then everything in there will return to that form. Often you'll just see them, it might have that quip card this cast at the top, but then everything inside the mark matching might cast to like the cards, quip card type of state.
And just in case somebody's slow like me, the cards
Mhm.
this in Cell and Ser after that, that says, okay, now you have cards. You made that from the action that you called in the Palpar, and then this is just that state returned as the state for this current application.
Yes,
Okay.
we should just do yeah, exactly. And so I just want to emphasize that it's so we have we're basically satisfying the quip card this condition at
Mm-hmm.
the top,
Mm-hmm.
right? And what we're doing is we're saying you're right. We have the cards now, and this being, this isn't a special word. It's actually just like, the current subject.
Mm-hmm.
The current subject, we've also modified the state thing in it right here
So it's
with
the
a tit, with a
entirety
tit,
of
with
the
a.
subject. Yes. Okay.
It's the entirety of the subject, aka this door,
Got it.
right?
Yeah.
But with the state tis dotted.
Yeah. Okay. That
Okay,
makes
so
sense.
now further, when you look at the actual handler here, this handler function, we already know it has to return things. It's going to return things always pretty much in a quip cards. Let me just check one thing. Oh, that's bad. I did a bad thing here. That I Yeah, because I have helper core up here, and this needs to do handle action helper core. That's actually because now then my bowl. Fortunately, like I don't use the bowl down here, so I don't have an issue. If I search for bowl, it's probably not there. Yeah, that's why I didn't have any issues. But this is like a common bug where you forget to use the helper core with the bowl injected, and so then basically it just uses the default sample inside the helper core.
Oh, interesting. Okay.
Right, and I can show there's lots of ways that can cause bugs, but especially if you do scries that depend on that for like giving the current time
Okay.
and things like that. So common bug is to like forget to do that, and you'll often want to just do a debug print for your bowl if you're having issues in your helper core, to make sure that that's not the issue.
Okay.
Um, okay. So key thing though is that this handle action thing it casts to quip card state. Now the reason it does that is that it like how would I say it? Like this is really just saying list of cards and then state.
Hmm.
And so that's what we like. That's what we want. The head is a list of cards. The tail is like a state, and then we do everything up here.
Got it.
Okay. So just putting that there, we'll see a lot more examples of this. Like pretty much every program from here on out uses this form because it's just, it's really nice for this exact pattern. And the reason it's done is that if logically what you're messing with is state and not this, it just makes a little more sense to be explicit about that. But you could do it as, this.
Could Okay, because this would still refer to the top door, not the helper core, because that's how it's defined. Right. Okay.
Oh, actually, yeah. Actually, let me think. That's a good question. No, you're right. You're right. Yeah, you actually, if you're gonna put it, yeah, if we put our handler in the main core, then we could use like, this in our Tiscat. But because we're in the helper core, it shouldn't have access to that. Yeah, it doesn't have access to that name disk. It's actually declared afterwards.
Oh. Okay. Right. Okay.
Right. So actually, we do have to use state, which is already like jammed into the subject, as we've seen, like up top.
Got it. And then if somehow it did have access to this, then you'd be returning not actually the state, so you'd need to return the full this. So
Yes,
the tis dot would be a this.
exactly,
Okay.
exactly. And we could set the this state face to something
Yeah.
else.
Yeah.
But
Okay.
generally for that reason, because let it by making it state, it lets you kind of do stuff either in the helper core or in like a helper arm in your main core. It's always better to use state.
Makes sense.
Okay. This one, this lust syntax. Have you seen this one where you do now lust? Like, I mean, the example is pretty straight.
No, I haven't seen that before, but it makes sense what it's like.
Yeah,
I
it's
understand what's
really
happening.
it's just straight syntactic magic, and it's just an alternate syntax that's maybe just a little bit faster for basically pinning some kind of. Usually, it's for pinning a mark on the head of a list,
Oh, okay. Okay.
but you can use it to kind of a pin arbitrary terms to the front of a list.
Okay.
Okay,
Does that make a
so the thing.
vase?
No, it does nothing. It does nothing magical. Literally, it's a very dumb thing. All it does is it makes a cell where the first cell is this word turned into a term,
Okay.
and not a value. It's really dumb. Now, you're right. You absolutely could use it for a vase if we wanted to do something like noun loss, like like this. This would be a common use of it. So
Okay.
now I basically say it's a noun and put that there. This would be not well. The second part is a vase, and this whole thing is a cage.
Okay. Yes. Okay. So it's
Okay,
never gonna put
so
that typing in. So the term is not a type.
correct.
That's why I was getting lost. Okay.
No, the term isn't a type. It's a mark. It's a term that's often used as a mark. So this is a common syntax for creating cages.
Okay.
Then the idea is you want to have kind of an unevaluated term on the front that's often a mark, and then like the rest of it is some evaluated code that's often a vase.
Got it.
Okay, but you can also absolutely use it for these things like also tagged unions, types that are tagged unions, where you put the tag on the front and then have something on the back.
Oh, so that could be a straight up poke with like some instructions on how to do
Yes,
it.
exactly. And so, and since you see that sometimes, I'm just making sure to use it in this lesson to kind of get people familiar with it,
Got it.
because you will see it in other people's code. Okay.
Okay. Okay.
All right. Let me check one. I need to. I want to. I just need to open the lessons that I have it like here to refer because I have some stupid like typos, like shortcut written dumb way. Okay. All right. So moving on. So poke. Let's go to what poke is. Poke is just a one-time call,
Yep.
and it doesn't have. The only thing we know about poking is that if it succeeds without causing an error, it'll send an acknowledgement back. Okay.
Yeah.
That's really our only guarantee about poking. It can, cause other stuff to be triggered. So the receiver of the poke could do something like give a message back to the other ship, which could be handled in on agent, but there's no guarantees about what will happen. Okay, all that we're guaranteed of is that it will like acknowledge it if it succeeds, and Gall handles that.
What do you mean by acknowledge?
We'll see that in 1 second.
Okay.
Okay, and what we get back. But basically, it means that we'll get a poke in on agent.
Okay.
Okay, um, so on poke is a gate. It takes a mark and a vase. We're pretty familiar with those at this point. And there's kind of two basic formats you can use at the dojo to poke, which is useful to know in general.
Hmm.
So the first one is that you either mark it noun or just start typing your data. So that would be you type the name of the agent and then just start typing data, and that will go in as a noun.
Okay.
Okay, so we have in our on poke, if we have all these handlers for where mark is noun, and we can look at those for oh, let me copy it over here. All right, so it's watching changes. We can okay and start. Oh, and while we're doing this, I should start my timluc ship as well because that'll be ready. Okay, so poke time is there, and we can go ahead and just run. It does some printing of my state.
Hmm.
Okay, similar to like the kind of stuff that debug does. I also can send the mark as a noun, and it'll do the same thing, but you don't have to. So by default, if you don't do anything with like Pam and just go into typing stuff, it will just pass that as a noun.
Okay.
Okay, so a little bit of magic there. So usually what I'll do here is I'll like commit, do commit before anything else. Go out here, copy.
Oh, were you mounted?
Oh, good point. Yep, yep. Teamwork. Okay, so yeah, let's go ahead and mount. Okay, so we're gonna mount and then actually run commit one more time, so it's like the last thing in there. Copy our timluc to. I'll just call it back. All right, yeah, I just do like whatever version of like Urban it is, which is 0.143 or something. Okay, so now we've got that, and then I'll just do our timluc. Mm-hmm. And we're in business with commit as our last thing. Okay, so we got both of our ships up there.
Cool.
All right, so um, we we have but we have both those formats. The other one you can do is you can do a custom mark. Okay, it can be any kind. It could even be like text or something. Although we don't have a handler for that in here, so it would give an error. Right now in our on poke, we're handling the mark noun and also the mark like poke time action.
And that mark doesn't actually need to be defined in MAR, but could be. Is that right?
Um, yes. Well, actually, I think every mark is defined in MAR, but let me just check. Let me check that 'cause that's like worth confirming. Actually, no, all the marks are defined in MAR, even noun.
Okay. All right.
Um, so yeah, it actually does have to be defined in MAR.
And you made
Okay.
that in the action.hoon file for poke time? Is that right?
Yes. So it'll
Okay.
be yes, yes. So it'll be in MAR, poke time / action.hoon, and we can look at it and we can see it imports, the poke time, sir,
Hmm.
and then it goes ahead and does like if it has a noun coming in, it runs that mold, and anything coming in the dojo, like just the raw input starts as a noun, and so that's like what you'll often be doing.
Okay.
Okay. If you're poking from, like doing a poke from the browser, you can easily do it as just pure JSON
Yeah.
and say it's JSON. And so that'll often also have that. Although I think it's better to just like, define your mark and have it do, and, have it do the JSON parsing itself.
Sorry, I don't want to drill
Uh,
down on this, but then, sir, has a handler called action that handles turning a noun into either a noun or a poke time action?
Yes. And in
Okay.
fact, it's not even like a quote unquote handler. It is, as is almost always the case in these things, it's just a mold, a tagged union here.
Yep. All right. All
Okay.
right.
Super common pattern. You'll just see this everywhere. It's pretty boilerplate. Okay. And so if we want to run that, we could look at like what those things in SIR are. Um, wait, poke time. And we could be, wait. Hmm? Oh, I see. Okay, so we have it over here, and we could like run one of these like increase counter if we wanted.
Okay.
We'll look at some examples here. So we can do poke time, like poke self, and it'll just like hand like a few things happen here. One is that we have poke self here, and it goes ahead and let me just see. So a few things that I'll talk about this line here in one sec. It returns the usual like this structure. Um, it goes ahead and basically does a weird thing right here,
Mm-hmm.
where it goes ahead and pokes us.
Okay. Okay.
So take a look.
It
Or I'm
passes
sorry.
on the.
Wait,
Go
I'm
ahead.
sorry. I'm sorry. Wait. No, I'm sorry. It's not received. Yeah, no, that's right. Yeah, so it passes on the poke wire,
Uh huh.
and it does. Now our pass is to agent, so it's not Arvo.
And it's
Um,
our application that is the.
it's our ship, and then to the poke time agent, which
Okay.
happens to be us.
Okay, so that's the path and the agent there. R dot
Yes.
bull and poke time. Okay.
And then it does poke noun. Wait, I'm going for. Oh, so poke here. This is like as opposed to watch. So this means send a message to the on poke handler.
Okay. All right.
Okay. And the mark is this is our mark. It's noun, and here's our. So basically, the ending thing is a cage. So it's a mark and then a vase.
Okay. And then
Okay.
that automatically calls the next thing, which is
Well,
the.
in fact, what it does is it sends this message back up to Gall, which goes ahead and says, okay, you're going to send this message to the agent here in the application poke time. The message is going to be a poke, not a watch. It's going to be this final cage, and then this mark gets passed as the mark, and this vase gets passed as the vase.
I see. I see.
Okay, so it basically flows back out into Gall and then comes back in the top here.
And then how does receive poke that line just below
Mm-hmm.
what we were just looking at? That's not q dot vase. So how does that happen?
Yes, good question. So let's actually look at what we're doing here because we skipped over one thing, which
Okay.
is
Sorry.
we switch. No, it's good. It's my fault. We switch on the mark.
Yep.
We find out that it's a noun, as it will be here, and then we do another switch here, which is we check for what's in q dot vase.
Right.
Okay, and if q dot vase is receive poke with an atom.
Wouldn't that be the whole vase?
No, this the whole vase. Let's actually go.
Oh, right. A
Let's
vase is a type, and an. I'm sorry. That's where I was. I was just
Exactly. It's worth
expecting.
seeing
Yeah.
it here. So it's basically the type is information is here, and then here's the actual vase.
Okay. Very good.
Or sorry, the Q dot vase is there. Yep. We can kind of correctly match on it, and it'll give us a message that we see here, which is got poked from Zod with Val 2.
Okay.
The tail of Q dot vase. And notice how we can use src.bowl to see which agent caused this on poke arm to get like pulled.
Oh, show me the result again. Oh, it said from agent. That's right. Okay.
Okay. So like src.bowl always has, if there was an initiator of a watch or a poke, it lets us figure out who that was.
Okay.
Now, we actually use that up here, and I don't this is just so common, you'll see it like really often. All this thing does is it asks, is the source of the action of the bowl is it on our quote unquote team? Meaning, is it us or a moon?
Oh, okay.
Okay, you'll often see this assertion, and it really should be, or in most code, it will be at the top to make sure that agents can't be poked by anyone who's like not them or their moon.
Okay.
Now let me just find some examples of that real quick and like in app. It's very often done in the various stores.
You used to. I
Um,
don't know if you still can. You used to be able to poke helm with high on somebody
mhm.
else's ship, and like it would still show as you highing them, but you were doing it from their version of helm high, which is weird.
Oh, yep, yep. So a lot of programs have added in like this check here
Okay.
uh, to if your program is kind of logically meant to be even like group store isn't meant to be subscribed from like from other ships. It has some like kind of like proxy agents to handle that. So both its on watch and its on poke have this kind of access control.
Okay. So that's how they're doing
Okay,
that now. All right.
so that's really standard access control that you'll see a lot, and I just have it in here as an example, which is
Very
like,
cool.
oh, you say you want to poke self, you can only poke self like from self.
Got it.
Okay. Um, all right. That's like most of that there. Now, let's the final thing we see here is a message that they're a successful poke act.
Hmm.
Okay, so three things happen. We sent an outgoing poke to ourselves, we handled the poke to ourselves, we looked at all that. We got back a poke confirming the poke was received. So I have a lot of writing here that says what I just said in like written form. If we go down to acking the poke, whenever you send a poke or a watch, you get back something in on agent on your wire if it was successful.
All right.
Okay. And sometimes if there's like errors, you can't guarantee this, but if there's actually an error thrown by the agent, you'll also get like a negative act back with the error in the stack trace. But if it just never goes through or something, or the action is invalid, you'll never get that back. So you want to depend on that less than like the successful one.
All right.
Okay, for an example of what let's look at the poke act, then I'll show you an example of what I mean by that.
Hmm.
So here in on agent, now this is remember we're doing on agent because our poke and watch acts come from other agents.
Right. Okay.
Okay, so it comes back over here, and we switch on the wire. We say we see which one it is. Here it was this poke wire, right?
Yeah.
And then we say if the sign is null, then it's successful.
If the sign is no. Okay. Okay.
And successful head of sign, which is like Pokak, successful Pokak.
Okay. I'm trying to track why it was null.
Yeah, let's look at what we're going to do is we're going to look at usually the thing you want to do here is just like refer to the type itself.
Okay.
So we go to Gall, and this is a sign, like the type is sign agent Gall. So we go down to agent, we look at sign, and we see that it's either a Pokak and then unit tang
Okay. And
or
he.
Watchak
Go ahead. Sorry.
or Watchak unit tang or factor these things, right?
Yeah. Okay.
So if it's like if the tail is like null, it means nothing came back, and the unit tang is going to be like an error message if there was an error.
Got it. Okay.
Okay, so for a practical example of how I use that, it would be like right here in picky.whom. And I use it when I'm do, 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 do. Lots of code here, but yeah, when I ban a user,
Hmm.
I go but like in my on agent, I check and I say, is the wire ban user and is the thing coming in is the sign Pokak? And if it's Pokak null, then I like right here. So basically, I first match ban user, then I match Pokak.
Yeah.
And if it's null, that means it's succeeded. So I go ahead and add the user to my like banned list.
All right. Where would a tank the unit tang be created for an error message?
That would be created on the, like, let's call it the server, like the one that gets poked, the agent that gets poked,
All
and
right.
then it has some problems, so it sends that back.
All right. All right.
Okay. So there's basically a few things. So a few things can happen. You can either act, or at any time, an agent can send you, another agent can give you like a fact. And what a fact looks like, this is basically when an agent wants to like return you data. Okay. And so a fact looks like a cage.
Okay.
So later we're going to see an example where we match a wire, and we check to see that it looks like this counter, and then we check to see that the sign is a fact.
Okay.
Okay. So a lot there, but I think the basic idea is pretty straightforward, which is we send a poke to ourselves, we handle it coming back. Let me just get one thing in here. Okay. Um, we handled the poke, and we got a poke act back confirming the poke was received.
All right.
Okay. And what I was showing with the picky example is that you can depend on that positive act.
And not on the negative one.
Yeah, exactly.
All right.
So it's best if you have logic that like does some like handling when you get the thing back. You generally want to do it on the positive. So in that picky implementation, there was an alternative that I used at first, which was ban the user right away, and then if I get a negative act, take them out. But that's worse because like the other ship could just never respond, or the error might like be one that doesn't like throw a stack trace back, and so you don't want to do it that way.
Okay. That makes sense.
Okay. Um, Next up, sending. Let's see. Sending a poke to an agent. We have custom marks for poke. So we were using our noun, and that's, I don't know. It's convenient if you just want to do stuff really quick and dirty. But for almost any application I have, you almost always end up creating like custom marks, just to let you do some more data validation.
Right. Right. And this is
It
why
lets
we
you.
go ahead.
Sorry, go.
Well,
Go.
this is why we build those. Why in the last lesson we're learning about how those marks are created, so that if we need to start changing like JSON into one of those complex types that we're validating, we would use like a grab arm. Is that right?
Yeah, That's exactly right. You would use a grab arm to grab the JSON and turn it into your type.
Grab arms and the marks who love them. That's terrible. All
Exactly.
right.
Um, so, um, what we're going to look at here is an action type that can have a couple different types of actions. And I want to emphasize that when you're reading other people's code, it's often really useful to go to their like usually SIR file and see what like action type they define.
Okay, that makes sense.
Okay, and most of them have some kind of like action type, as we saw with chat here.
Hmm.
So here's ours. It's an action. Increase counter, like remote, like self, drive. By the way, one question that I've seen, I think Pastic answered it. If we wanted to do like new action, and it just didn't, like, let's say it was like increment counter,
Hmm.
and there's no kind of logical thing to put here, but you can't have a tagged union with just one element. You can just put a null.
Okay, that's saying it's not going to get any information. It's just going to increment the counter. But when you pass that, then you have to have a null in that.
Correct. Correct.
Okay. Yeah.
Okay, so that's like a pretty common pattern. Um, and to do it, as we saw, we had in poke time action. We just say if you have a noun coming in, make it action poke time, like
Okay.
run it. Pretty straightforward. And the nice thing is, if we do something invalid, it'll give us an error. about our thing there.
Could you do something really stupid and have like
Yeah.
a tagged union where it accepts any tag as the head as like a catch-all case in your SIR file? Like I know that that would be
Um.
dumb, but I'm just would it
Yeah.
do
Let me
that?
like
Like if you just said
catch
like
anything.
tar instead of a tag.
Yeah. There's definitely a way to do that. You would do a tag union as you would make one type like a subtype, and then have your action be some kind of like union of that with the thing. Like it could be, you could. Fuck. There's a way. There's like definitely a way to do this.
Okay.
I just have to like look at the exact tune. This is actually more in your, up your alley, to
I
be
think I
honest.
could figure that out. Not that it would
Yeah,
be
just
useful to do that, but I just,
yeah.
it's
There's
good
some
to ask
times
dumb
when
stuff.
you want to have like a catch all, but yeah, you could do it.
Okay.
So here's using our like Lust syntax. Here we can do like poke remote timluc. So first of all, we're gonna need to. Uh, mm, I'm gonna also need to run. Okay, so I'm gonna install this on timluc.
Cool.
There's all that. Start poke time. This using this like new script that we have. And then what we can go ahead and do is we're gonna go ahead and run this poke remote action timluc. So, looking at how that works, it sees the mark is poke time at. Well, let's first watch it happen. So it did it, and then over here, okay, I definitely tested this. Poke remote. Yeah, so it's seeing Zod. That's actually weird. Hmm. Okay, this is not like I definitely had tested this before. Anyway, you should see a successful POCAC locally and a message on Timlook, because what it does is it sees the mark here.
Mhm.
It yanks it, runs. I just print out here what the action was inside, just for diagnostic purposes.
Yep.
Um, Handle action, it extracts the action there and sends it to handle action. So if it's poke remote, it'll be like
Pass on the
pass
wire. Yeah.
on poke wire to target dot action, and then it'll say receive poke 99
Okay.
coming in. Now if it's not doing that, that's like a big problem. So I want to see why that's happening, because I need. Oh no, there it is. They actually both came back. It took a.
It just
Oh,
took a minute.
I bet I know why. So probably because we had these two things set up like locally, and then we did this one like way later, or maybe we had an earlier one that was deleted. I think Zod had to like get like updated networking,
Oh, okay.
local networking. So then it gets
Stupid.
to. So yeah, but notice we use the same poke wire, so it comes back right here in the same place to Zod. It says successful pokeac and does that, and then this one gets the receive poke and prints out the value, which is 99 in both cases.
So if you wanted to make a custom wire for each ship that you were poking, let's say, you could use like some sort of path syntax in creating
Yeah,
that poke wire.
absolutely. In fact, it would look like this. You do this, it would look um, like that.
Okay.
You just end
Fascinating.
up using this so much for paths that you get used to it. But Scott P target dot action basically turns that into a tape.
Would it
It turns a ship into a tape.
would it be prudent to do that ever? Like, is it good to have separate
Yes.
wires? Okay.
In fact, in that exact example I was showing you in my app, I actually do exactly
Oh,
that.
right down there. I see.
Like in this on agent, like it goes and it parses the resource. Or so actually right here, it actually does Scott P on the entity of the resource, which is a
Mhm.
ship,
Mhm.
and then the name of the resource, which is a term, and then it does Scott P on the user, which is the user we want to ban, which is also a ship, and then it like kind of reparses them out over here.
Do you ever have to destroy wires that you create like that? Like, is it good to turn them off? Can you turn them off?
No, no, they're not turned off things. They're just like an identifier for an outgoing request.
So a wire's not really extant. It's just an identifier.
Yeah, it's just an identifier that you kind of, have to handle.
Okay.
And we can kind of, one way you can kind of confirm that. Wait. Oh, for this one. Okay, so by the way, I actually don't have that here. Interesting. So I don't have this one using, it's actually using all of the bad stuff because I don't want to change the line numbers yet, like putting version state right here. And it doesn't use debug either, so I don't have that bool. I only have this like stupid
That poke
print
one.
state
Yeah.
print state noun, which doesn't. Ugh. So we can actually look here, but this is the bowl, and notice that it doesn't have any wire information inside it.
That's really interesting because, like, I guess it's just fascinating to me that like a wire feels really real to me. I don't know why, but it's not really
Yeah,
real. It's just a
all it
designator.
is it's a name that you make during your program, and that if you want to do anything with it, you can do in on agent and on Arvo.
Okay.
Okay, so it's basically just kind of it's more of an internal reference for your program, and Gall doesn't need to keep it as metadata.
Okay.
Um, moving on. This is like a pretty long lesson, so I'll
Sorry.
keep knocking through. Just make sure my voice holds up. Um, okay, so we go down here and we have like this one, which is like poke ourself, which will work. Not so interesting, but we can go and do it. Um, it gets like successful poked from Zod with Val 2.
Hmm.
I want to actually see something here if I do. I wonder what's okay. This one is gonna fail. Yeah, so it failed. We get a poke. So actually, here is an example of getting like an error back that we don't handle
Mm.
on poke wire, because this is basically pokeac with a negative, with like a stack trace basically. And the reason it doesn't work is that we try to poke timluc,
And we aren't in
and
the
it
team.
doesn't. We have this. Yeah, we're not on the team
Yep.
exactly. Okay, so again, here is like one where we can use to like print our. If we check the print state, we see here our counter is 0. Here we're gonna like do an action to increase it by 7, and we'll see that it increases. Now counter is 7.
Hmm.
So this is you can update the state when you receive a poke, which we handle here in like increase counter. All it does is a tis dot counter dot state, and it adds the amount inside the action.
Okay.
So key pattern here that you'll often see is that we have various like variables in here basically, and we can refer to them by name by getting them out of the face from our action.
Hmm. Hmm. Okay.
Once we pattern match against the given head.
Right. Right. Okay.
Okay. And now here we're going to get into this is like subscribing, so we can see like a little preview of it. So let's go here and we're going to say subscribe to timluc. Got counter subscription from Zod. And now when we look at our bool, we should see that inside like sup incoming subscriptions, there's a subscription.
Okay. So that does exist. Okay.
That is tracked by Gall. Okay, and notice that if we look at my handling for it, when I say like basically do this action of like subscribe and it pass like a watch on the counter path,
Okay.
okay, I don't really do anything there except print out got a counter subscription, but Gall now records the subscription.
Okay.
Okay, and then here we're gonna do this one like this action leave, which goes and it passes a card to on agent to the host that we want. In this case, it'll be timluc,
Hmm.
to the agent poke time and saying leave. And again, we don't even have our on leave handler. All it does is say got a leave request. It doesn't do anything else. But our leaves wait, hang on, that's wrong. Oh, wait. Why would I do leave Zod? I think that's a weird like host. It should be leave timluc, right?
Is the Wex on Zod the ones that it's watching?
Yes, Wex is the ones that it's watching. So actually, I think I need to make like a adjustment here. Yeah. So here's we have it in the Wex.
Yep.
I think it needs to leave timluc actually. So let me just update that and then update that in the lesson. Okay. Yeah, I got counter leave request from Zod.
All right. All right.
Okay, and now if we check out the bowl, we'll see that Wex and Sup are empty, and here Wex and Sup are empty.
Interesting. Okay.
So the key thing here is that Gall is handling all of this for us. Okay?
Yep.
And the other key thing is that I need to change that thing to be timluc. Okay.
And just so I'm thinking about it right, like if this application had meaning, then the subscription from Zod to Timluc would allow Zod to receive information from the counter
Yes.
part of the. Okay, right.
Yes, exactly. So the first part here is like that when it passes it, this is like a wire for its
Yep.
own purposes. And then sorry, this up here is the wire for its own purposes. And then this is the path. And so timluc, when it wants to send information out, will do it on that path.
Okay.
Okay. In fact, that's actually interesting. Well, we're going to look at this in the subscription. Well, let's before we get to that suspense, we'll just go to the subscription part.
Okay.
Final thing here is because this is a tagged union with a finite set of values, we can use like what hep
Which is my
to
favorite
go
what
through.
rune?
Exactly.
It's a cool one.
Um, yeah, just because it can check that you have all your cases,
Hmm.
so that's nice. Yep. So how subscriptions work? Pokes are like one-time calls, almost like function calls or like procedure calls, and subscriptions are basically like um, yeah, I mean, they're exactly what they sound like. The other app can send information to you whenever it wants, and usually you'll often like read its source code and see when it does so, and then
Okay.
decide which one you want to subscribe to, or maybe the app maker like writes documentation about like subscribe to this in order to X, or maybe it's like you have multiple agents that you have interacting, and this is just how you have them communicate with each other.
Makes sense.
Okay. So let's talk about wire versus path. We said here like Wex is like holds like a wire,
Hmm.
which is this counter timluc, and then here Sup holds a path, which has like a lot more information. So it's this thing here, this Q equals counter.
Hmm.
Okay. Um, so wires, as we talked about, those are like just purely arbitrary and are on the like subscriber side. So it's kind of for subscription metadata, like getting acknowledgments that your subscription happened, or saying, okay, I want to leave this subscription. Here's the wire I subscribed on.
Hmm.
Okay. And path is kind of for the content of the subscription, being like, I have these subscribers, send them info on this path, or kick, X subscribers on this path.
Okay.
Here's the subscription workflow. The requests are created with pass cards. Okay, so those are like what we have right here when we pass, and we do it with like a watch instead of a poke.
Okay.
So let's do a contrast. Like up here, we have a poke pass. So pass, poke wire agent. Here's the ship and agent to pass to,
Right.
and then poke with a cage.
Right. Okay.
Here, exactly the same thing. Pass, a wire, agent, also like the target.
Hmm.
But now we do watch instead of poke, and instead of a cage, it's a path.
I guess okay. I have trouble understanding where the path is defined. Like, how does it know that
Yes,
this?
yes.
Yeah.
The answer is yeah. So the answer is, um, it doesn't have to be defined. Basically, it's handled by the ship you subscribe to. So let's actually, I think this thing is such a stripped down example that it helps us understand that. Um, what happens is how is this? The path is defined in on watch.
Oh, okay. Okay.
In fact, and that's so simple that I should just write it here. So if you want to see what paths something accepts, you just look at its on watch.
Okay.
If we didn't have
That
this,
makes so much sense.
we yeah, and it's actually important to note that if we didn't have this, we would get an error. Okay, so let me just think of a quick way to demonstrate this. Would be let's change our subscription thing to be on count A instead of counter or count. Let's say we just messed up the typing.
Sure.
And so that copies over to here. We're going to go and actually update. Can I update? Let's see. Digital update. Okay, so we recompiled it using the new poke time hoon, and we're going to try to send out this subscribe action. And this should give us an error because timluc doesn't have a count path. Yay!
Okay.
Subscribe failed from poke time on this wire. Right? Notice that our wire has counter, but timluc never sees our wire.
Yeah, it's arbitrary as far as timluc's concerned.
Yes, exactly. And I want to actually talk about a few things here because we could even handle this. Um, subscribe failed from poke time on wire watch. I want to look at actually just for my own purposes. If we look for watch act, we don't have anything to handle watch act signs here. We might want to add one because I want to show. Um, I actually want to look at what happens because we actually get this full stack trace here, which is the stack trace from timlock.
Right.
Okay, and that's being handled, I'm pretty sure, by default agent. So I think I want to show that real quick in lib. Yeah, here's on agent. So watch what happens. We get this thing back that's on our wire, counter timlook, but because we're not matching anything for the sign watch act, it doesn't do anything. Right? So it basically means the default case has to handle it.
Okay. Right.
So that gets thrown over to here. It does match the watch act sign, and it says if p dot sign is null, then just go ahead and everything's good. Just return, unit agent. But if there's something inside watch act, meaning that we have something in that unit tag, let me just show the thing here. So we're checking for the sign. So
Right.
if p dot sign is not null, it means we have something in this unit tag, and so it goes ahead and says, okay, make it into first make a tank of
Yep.
leaf subscribes just to log it, and that's we end up subscribe failed from poke time wire on the wire, and then system log tank and our UP sign, which is the basically that tag that got passed back.
Okay. Okay. That makes sense, and that's interesting that that's the so you use that as the default case because that basically, if it got anything in the watch act, fails. And I guess the success case there that doesn't give you that just gives you tick agent back is like if you sent a watch act but it didn't have any. Yeah.
Well, yeah, exactly. If it worked, if the watch worked, it just basically doesn't a no op, just returns our current agent.
Okay, so this is just if you had a really simple.
Yeah, and by the way, that's actually really common. You often will just be if I get the watch act back, don't do anything because Gall's already handling all this. If we look at the bowl itself, right here, or we can look at our prior version when we did have the Wex,
Yeah.
it keeps track of the wire, the ship you're subscribed to, the application on the ship, and also keeps track of whether it's act.
Mm-hmm. Mm-hmm.
So you can actually dig into your bowl and your Wexes and be like, I don't do it for this lesson, but it's very easy to be like, okay, hey, take my bowl, get the Wex in the bowl, and then print out all the wires that are act, or all the outgoing subscriptions that have been act and haven't.
Okay.
Okay. And it also does know what the path is on that other ship, even though we don't use the path.
Okay.
Okay. So there's just Gall is handling all of that, even though, as we see, the default thing doesn't do anything.
Got it.
Right? This all gets handled at the Gall level, and that's purely optional. Often, what'll happen in on watch, all we do here is print it out, but very often, and I think I'm gonna make that an exercise in here. Um, so stuff like this, and then watch acts. Okay, so these are some things I want to explore in the exercises that I think are pretty clear. But basically, my point is, often what you'll do in on watch is you'll get the thing, and instead of just printing out a stupid message, which you often usually won't do, maybe you'll return all of the information to that point. So if someone subscribes to Chat Store and is give me all the updates to this chat in the future, you'll also send them back the entire chat up to that point, just for kind of an initial thing to seed it.
So this one might send back the current counter state,
Exactly.
Okay.
In fact, that's probably we'll look at how to do that in a second.
Okay.
Because I have an implementation of that. But the most reasonable implementation in this on watch actually would be to give back the current counter state. I just do it in a weird. No, actually, I don't do it. That would be the most reasonable implementation. Would probably be to have some helper core arm, pass current counter state to subscribers.
Mm-hmm.
And we could make that. I'll show you how we can make that change. But that would be the most reasonable implementation. Okay, so subscription workflow. You create them with pass cards. They contain the wire so that you can listen for your act, listen for any actual updates that come in, and also leave if you want.
Got it.
Okay, and the path that the host will send updates or kicks on. And as we've seen, that's for the host's benefits. The host knows where you're trying to subscribe.
Right.
So wire is for your benefit, so you can kind of sort out all your internal logic with what you want to do with the subscription, and then path is so that the host knows what you even want in the first place.
That's a really helpful distinction.
Okay, cool. So I think here is the really technical distinction, and that's kind of the user distinction. So I should even probably say wire is for you to decide how to process returned data, and then path is so that the host knows what you even want.
Mm-hmm. Mm-hmm.
And they're not. Well, the whole wire pathing isn't super crazy, but I agree that it's useful to kind of piece it out and have the motivation. So subscriptions can be unilaterally terminated. If I do a leave card, if Gall handles that, I'm gone from timluc, even if timluc throws errors or something. Okay. So you can, and also hosts can kick you, and you can't do anything about it. So when you have so even if you process the kick and say the key thing is that there is an on leave that we have here, but the leaving isn't conditional on our handling it. The Gall lets you leave whenever you want.
So neither are conditional on the other side accepting the action, is what we're saying.
Correct. You can always kick and you can always leave, and it doesn't have to be implemented correctly.
All right.
Okay. New subscription data flow. So that's kind of how you do them, and then here's what happens. The subscription card is sent and it's received in OnWatch. Gall adds the subscription to Wex in the subscriber, It adds subscription to sup in the host, like calls on watch, and sends a watch ack back to the subscriber. And the subscriber receives the watch ack in on agent. And when it receives it, it also sets act to true.
Oh, in the Wex.
Correct. Gall sets like, 1 second, just to get one thing out here. To true in Wex of the subscriber. Okay. Um, and then to end it, the subscriber sends a leave card. Gall removes the subscription from Wex and the subscriber. It receives the leave notification in the host, and it removes the subscription from sup, and on leave is called.
All right.
Okay. So some examples. We've already actually done the one where we subscribe to timluc and we see what happens, and how it generates like that whole card. Um, let me. Okay, I'll go. Keep going there. And also we looked at how like act is set to true. Now subscription updates. Let's go ahead now, and we're actually going to go and redo the subscribe because I want to show basically how like the sender can send updates. So we're gonna go ahead and subscribe here. Whoop. Oh, right. We actually need to fix our code. Still getting that counter error. So let's go up here, fix it there, subscribe, yay. And again, let's do print state, and we'll see we have the outgoing Wex.
Mm-hmm.
And in here we got counter subscription from Zod, so we don't. I mean, we can look at it, but it's in sup. Now, what we're going to do is run increase counter. Before I run it, I'm going to look at the logic to follow it. So the increase counter action, it updates our counter
Mm-hmm.
to be like increment it by the amount of step.
Yep.
And then it goes ahead and it actually, in addition to like updating that state, it gives a fact.
Okay. And that would normally be handled up above on the like on the on watch for that specific type. You could put that there to give it initially. Like this is my current counter.
Yes.
Okay.
Yes. Okay, so we're gonna look at this like at this thing because it is a little bit important to get, and I want to see where. So fact is a paths, list path, and a cage.
Why is it a list of paths?
That's what we're gonna look at.
Okay, sorry.
The answer is actually pretty simple. Notice here that we're doing it. We're sending this fact on a like our counter path.
Mm-hmm.
Why would we possibly want like a list of paths?
Oh, I guess you could subscribe to a delimited subset or a larger path that maybe contained additional data, and on both you'd want to update when that one data point
Yeah,
changed.
exactly. There might be multiple subscribers or multiple paths that care about this change.
Okay, that makes sense.
Multiple paths for like give, and there are examples of that. I can give hints on where they are. So here we go ahead and do this, and now notice we're going to see that we should get like, okay, so we increase. Oh, so actually, if we increase our counter here, that increases it in here. That's cool, but nothing happens in terms of subscriptions. Here, when we increase our counter by, let's say, like 45, it does that, and then we in Zod we get a message saying counter val on timluc is 45.
That's
So to
interesting. Cool.
walk through what happened, I increased the counter here locally.
Yep.
We can look at our state and see that it's 45, and he gets a message saying it's 45. Okay, and note now if I go ahead and increase it here by like 60, now it'll be 105 here.
Mm-hmm.
Okay, and we get that message back.
And that's handled by the on watch arm.
Actually, let's think about that. Where is it going to be handled in Zod? So Zod is subscribed to Timlook. Timlook updates its counter and gives
Okay.
that card
So
here. Where will Zod get that message that like something happened in this subscription that you're watching?
right. So on watch only happens when you receive a watch request. So it's either
Yeah.
on Arvo or on agent, and I have trouble differentiating those. I think it would be on agent.
Yeah, and why is it on agent and not on Arvo? It's pretty easy to differentiate once you figure it.
Because agent is other Gall agents and Arvo is other veins.
Yeah, so think Arvo is like locally, it's just your veins on your own ship,
Oh,
and
okay.
on agent is the only way you can remotely communicate in like Urbit is by like kind of passing stuff through Gall to other ships.
Okay, that's good to know. I kind of thought maybe veins could talk to each other too, but okay, so
I guess AIM sends out packets and stuff
but
like
that's
that,
beyond
but
me.
yeah, and for like and most of that is like yeah. Let me just think real quick. Like yeah, I mean you can, I guess under the hood, Gall does use Arvo to implement that and stitches together pieces of Arvo to do that. Basically, aims.
Mhm.
But for kind of easily accessible stuff and what anyone who's programming the system is using day to day, it's all being mediated by Gall.
Okay, that makes
Okay,
sense.
and then Arvo, on Arvo is basically stuff you do on your own ship, like timers with Bane, files with Clay, and then HTTP stuff.
Okay.
Okay, pretty. No, I think you're getting the hang of it pretty well. It's pretty straightforward. So we gave it this. We made the mark be an atom, and in the vase we just put the state. Right, because the state is just like if we look up here, it's an atom. So we're like, all right, we'll mark it like that, and there is an atom mark.
Okay.
Okay, so in on agent, our wire here was that like counter ship. So we match if it's counter ship. And basically this is like imagine if there was other ships besides Timluc running the same like poke time agent who we had subscribed to.
Yeah.
This basically just lets us like say, whichever one of them it was. And actually we don't really need to like make our wire could just be counter, would probably make more sense. Or even like poke time counter. But sure, we match it. We check the sign. If it's a fact, then we extract the value,
Okay.
like right here from the vase.
Q cage sign.
And so sign is our sign. The sign when you're doing a fact, the sign. So if we have, let's see, so sign. If it's a fact, then the thing here is a cage.
Okay.
So we get the cage face, then we get the Q face of that cage, which is the vase, and then we just extract it as an
Okay, so
atom.
saying okay. All right. That makes sense.
Because essentially we know that we basically looked at that app source code or looked at its specification and we know that it passes back atoms.
Okay.
Okay. And then we just print out what our source was, meaning that we can say that Tim Look is the one who passed us this value, and it's Val.
Okay.
Nothing much more to it there. And then we have here, where does it listen for updates and on agent.
Oh yeah. Okay.
So Watchak and Pokak are when you like do a poke or like ask to subscribe, and then the fact sign is when you're actually getting stuff for a subscription.
Yes. All right. All right. And then a kick. What does a kick? A sign kick. Does your ship receive that and then automatically terminate the wax?
Oh, good question. So I actually should have had an implementation of this here, but when you get kicked, you'll get this kick sign back on the subscription wire.
Oh, and then you can either handle it or not, but like the other
Yeah,
one
you
doesn't
can
give a
do
shit.
something. You exactly. If you have
Okay.
some processing you need to do after you were kicked, you can do that. But it's just a courtesy notification in case you need to do some processing.
Oh, okay. It's showing you the
Yeah,
door gently.
yeah. Well, not even like you're out the door, but you can pick up the pieces of your life how you want after that.
Got it.
So leaving a subscription, we have this one that we've already looked at. Leave. It's most interesting. We already know that it'll leave, but I can prove it. and got the counter leave request from Zod, and as usual, we'll see like there's nothing in Wex and Zod.
Hmm.
Um, Now it returns this card, which is basically okay. Again, this wire is arbitrary. I could make it anything
Right.
for my leave. Um, Basically, actually, it's a really good question. I should kind of, I should probably demonstrate that. Um, Once we leave, notice how we don't pass any information here in the leave, like the leave card.
Hmm.
So all that happens there is Timlook gets it in the poke time agent, and it just gets rid of any instances of our ship that we're subscribing to it, even if we had like multiple subscriptions.
So you can't leave like one path but maintain another?
Yeah, that's correct.
Interesting. All right.
Yeah, yeah, exactly. It's kind of interesting, and we're just like kind of worth knowing. Um, so on our on leave function, as we looked at, all it does is print a message. Gall handles everything.
Yep.
Okay. So kicking a subscriber from the host, let's just go ahead and resubscribe again, like in here. So we subscribe, we'll get our um, got the counter subscription from Zod, and in Timlook we're gonna just run this poke time action to kick it, which is basically kick Zod from this path. If Zod was subscribed to multiple paths, that you actually could just kick it from like one.
That's weird, right? Like that you could kick.
Yeah,
Hmm.
it's yeah, that's how it is. Whoop, that won't do anything. This one will. Yeah, and if we look at print state, we should see no wax, no sup. Um, One thing here, if you pass an empty list of paths instead of like counter, it'll just kick Zod off of all paths.
Okay. Cool.
Okay. On leave is like not called here on Zod. Okay, so that's kind of important. So um, mm, let me just check. Oh right, so here we basically had Zod doing the leaving.
Hmm.
Okay, and so Timlook gets the on leave arm pulled, but which it makes sense. If Timlook kicks it, then leave isn't called here anywhere.
Makes sense.
Okay, and actually like the only thing Zod finds out, I should put this in, but it'll get a sign that it got kicked.
Okay.
At least it should. Okay. Let's if you subscribe on a non-existent path, which we'll do here. We already looked at that earlier. We made our modification for count. So here we get this bad path because the path isn't implemented on Timlook.
Yeah.
Okay. Um, okay. A couple, and as I say here, it's in the default agent implementation. Odds and ends, you can have multiple subscriptions to one path on a host. Okay, so and the way you do that is you make multiple wires to the same path.
Why would you do that?
I don't know, but you
Okay.
could.
All right.
This is just for, that's why it's in odds and ends, just for
All right.
complete.
Sorry.
It's just, yeah, no, it's a good question. It's just for completeness.
Yeah.
Probably I can think of a use case. A kick from Timlook on the counter path, it'll kick both subscriptions.
Okay.
Okay. Factor kick. So a couple little weird things. They both take list path and unit ship.
Okay.
Okay, so if you have a fact, be like paths, list path. So basically, okay, we're giving a fact and we give it to all these paths. And then kick, we're kicking things on these paths and here. A little bit of a weird thing, and this is something you can kind of review afterwards. The null behaves differently in on watch. In on watch, if you make your in fact, if you make the path be null, then it sends the fact to the ship that is subscribing.
Okay.
Let me give an example of this because I think it's like a little bit helpful. This is in like rote.hoon. Um, Let me go to on watch. Okay. So here, wait, where did I do this? Okay, he does it right here, which is this is basically inside and on watch. And the first time someone subscribes, it says like give them like a fact and do it on this null path, which means give it to the person who's subscribing right now.
Okay.
Okay, when it happens in on watch.
Okay.
And kick uses it to mean um, if you do kick null null in on watch, it means do it on the path that was subscribed to, like kick them off that path, and do it for the ship that's subscribed. Like right here. So here, this is like weird. He basically gives them a fact when they subscribe and then kicks them right away.
Okay. Interesting.
Okay, that's just probably just for demonstration purposes.
All right.
Anywhere else, fact isn't allowed to use like that. You can't say send to all paths who are subscribed, where I have subscribers. You have to choose paths. Kick uses it to mean all paths and all ships.
Okay.
Okay, so fact it can use it to mean on the the ship who triggered this like on it on that path. And kick you can use it to mean the path that was subscribed to and the ship that subscribed. But in anywhere else, it just means all paths and all ships for kick.
Okay.
Okay, so best practices. Switch first on wire and then on sign, since you could have multiple wires that each get facts. Concrete example of that. Just like right here, notice how I first switch on the wire
Mm-hmm.
and see which wire I'm getting it back on. Then I deal with the sign.
Yep. Okay.
Okay. Some apps break that if they only have one thing they do, and that's fine. As soon as your agent has multiple, different, things it subscribes to, you'll often want to do first switch on the wire, then on the sign.
Okay.
Okay. Um, Use noun pokes only for simple debugging purposes, and even for that, I would mostly use debug. But there's some times where maybe you want to just poke it. Simple debug would be you want to run some action in development, just kind of watch it happen. So
Mm-hmm.
you can use a noun poke for that rather than polluting the actions for your custom mark.
Okay.
Okay,
Makes sense.
kind of like my random poke self stuff.
Right. Right.
Okay. For anything else, like for real pokes that you want to accept, create a custom type and mark for them.
Okay.
Everything around subscribing and unsubscribing, Gall handles. So if you need logic for cleanup, go for it. But otherwise, just let the default handlers do the work in on watch, on agent, on leave.
Okay.
Except for the fact that in on watch, you do need to implement the path.
Otherwise, nothing gets sent back.
Yeah, otherwise because the default implementation for on watch, if you look at default agent, is just a crash. So on watch, if it has a path come in and it doesn't know about it, it just throws an error.
Oh, okay. Great. Okay.
Okay, so it's good to know. It means you can just look at a apps on watch and know what's happening.
Right. Okay.
Okay, other stuff like figure out what a subscription does. Search the source file for give fact, or even just send give. Example: if I open up let me open up a real thing here in that chat store. If I search for send give, I can find everywhere where it sends updates.
Okay.
Update subscribers. So I can just kind of start figuring out how it what it does on its various paths.
All right. That makes sense.
And then only allow own pokes if your thing isn't really robust and set up to securely handle pokes from the outside world. you generally want to just put this at the top of your on poke.
Right. Right. Okay.
Okay, which you'll very often see at the top of like on poke, because on poke otherwise is like insecure and can just let anyone come in. But here, for example, Chat Store, we already saw Group Store does it. Most of these store apps, these like kind of local databases, they limit any poking to like their own team, and then like their own team can kind of implement custom agents as proxies or layers on top of them if you want to expose stuff to the outside world.
Got it.
Um, Finally, when you see lines like this in the dojo, now they probably make a lot more sense when someone gives you random code to execute.
Mm-hmm. Mm-hmm.
Like you're like, okay, it's the so the first thing is what is this first thing?
That's the agent.
Yep. Next thing is
That's the mark.
yep. And then everything after that is a thing that gets parsed into the mark.
Right.
Right. So in fact, we could actually go up here, and if I see that, I'll be like, okay, I'll just go to mar, file server action, and look at that. Okay, of course, which we can pretty much already expect. It uses like the thing from file server Oh, and here's all the stuff that like file server can do.
And that tells it what you should expect on one of those.
Yeah, exactly, and even probably what we could like pass into it. And so that's what it is, and we'll see a lot more of this coming up, especially with stuff like file server. So I'll add exercises. I think they're pretty clear. It's going to be a lot of like looking at how other apps like handle subscriptions and pokes, especially subscriptions, and maybe doing some modifications there. Um, do you have any like questions at this point?
I think I have asked them along the way. This was really informative. It's really interesting how much this can be illuminated over the course of like an hour and a half or however long we've been here.
Yeah, we're getting very, very close now to like you're probably at now like if I look at what's in overview here, Scry, except for HTTP stuff and maybe some JSON parsing, like you probably know 90% or more of what you would see in a random if you just like opened up a random Gall file.
And I know it for at least the next 90 minutes too, so that's great.
Exactly. That's yeah, I mean, programming Alzheimer's.
Yeah.
But yeah, that's it, like really, I mean, a lot of the stuff then is just like kind of the grunt data munging that you have to do to like do the thing you want to do.
That's the hard part, I
Um,
think, is that you look at these complex programs and you're like, oh my god, I don't know what. But if you break it down and really read through it slowly, you will understand what's happening.
yeah, and the general rule I would say for Gall programs, every language kind of has its own like size like this. Anything in the like 3 to 400 line size isn't that big because like so much stuff just gets taken up with like just handling like the state transitions or some on load, making just like handling the different actions for the arms, and then the actual custom logic here. Even a lot of this is boilerplate, but if it's starting at like line 157, like the custom logic is like probably like 100 or 200 lines. It's really, which is not very much.
Mm-hmm.
Whereas if you have something like publish that I think has grown kind of too large and out of control, it's not that crazy, but it's like 2,000 lines, 2,400. That is pretty big, and like there that does get to be like harder to kind of fit in your head exactly what's happening. Although even that, like large chunks of it, you're like, okay, handle notebook delta with all these tag unions.
Right.
Okay, this is like 400 lines of like, different kinds of updates to the book come in,
Okay.
and now we're down. Now we're down to 2,000 lines to think about. Right. So it's I would definitely say anything in that 3 to 400 line range. You should just be like, oh, okay, I probably just get what's going on.
Yeah.
And that's even like chat stores like 337. It's like not very big. You can figure out the whole thing.
Which is sort of amazing, I
Yeah,
think.
but it's just a small database that has to handle sending out updates of what goes in there.
Yeah.
So I might even that's like a really good question. I should like maybe for other lessons. I have to decide how much to do, but there's just like a lot of stuff here it's pretty straightforward now. They're literally almost, except for a little bit of scry stuff, there might not be anything in here that you don't understand. Oh, that's a bitch. That's something I should make people do for
What's that?
exercise. Oh, I mean, just like Yeah.
Well, you needn't spoil it. We can wait for those exercises
I
to come
mean,
out.
I'm fine. I'm fine to spoil it. It's basically going to be like figuring out the subscription parts of onloads. Um, like
Okay.
figure, yeah, like basically a lot of these have like a lot of logic they do once they make a state thing to be like, I no longer need to subscribe to X, or like I do need to subscribe to X,
Mm,
and that's like worth going through. I think
okay.
even more so worth going through because I've never made myself go through it, so other people can do it for me.
Perfect.
Exactly, it's kind of everyone wins except for
Yeah.
the
Except for me.
except for the
Right.
students. Exactly, exactly. All right, cool. I'm gonna leave it at that then. I think there's a lot of really productive exercises, and I think you're like kind of well on your way to seeing a lot of this.
Yeah, I think that I'm picking up what you're putting down, man.
Yeah, and anyone else who gets this far in it at the end, just feel free to put questions in chat for this because this is like probably the most important lesson I would say. There's others that are like have like a lot going on that we'll see and like interesting data, but like this is like the meat of Gall right here. So if you get this one, everything else kind of like spider webs out from it.
Cool.
All right, cool, man. I'll stop it there on the share.